Hi everybody. Here's a description of how to do the problem involving Newton's laws from exam 2. Two people push on a box with a mass of 30 kilograms, shown here as viewed from above. So here's the two people pushing on a box. We've got somebody supervising over here, and they push on it in such a way that the box starts from rest and moves a distance of 50 meters along the x-axis in 8 seconds. So it starts from rest and it moves in this direction a distance of 50 meters in 8 seconds. And so this person is exerting a force that looks like this, and this person is exerting a force that looks like that. And F1 is given to be 100 newtons, and it has an angle of 34 degrees with respect to the x-axis. So this is person 1. This is person 2 exerting these forces. F2 has a magnitude that is unknown, but the angle is minus 20 degrees, so this angle measured in this direction is 20. You could also put in a minus 20, and I'll show you how the minus sign comes into play. But the minus sign just means that it's measured clockwise from the x-axis, and the plus sign means it's measured counterclockwise from the x-axis. And so in this scenario, I saw an awful lot of people who drew a free body diagram that had the weight pointing down like this and the normal force pointing up like that, but that's incorrect. In this scenario, the way this is pictured here, the weight would be pointing down into the ground away from you, and the normal force would be pointing up at you because you're viewing this from above. And so the weight is not just some arrow that points up towards the top of your page. There were a lot of people that were confused by that. And so that was a little bit of cause for concern. So the other thing that people did that was kind of goofy was they took this 50 meters in 8 seconds and they just said, oh, velocity equals distance over time, 50 meters divided by 8 seconds. Whoops, 8 seconds. And then they said, oh, okay, so the velocity is 6.25 meters per second, and somehow they use that as the final velocity, but that also is wrong. My first question here would be, what equation did you use to get this? Okay, so this is completely wrong to do that, and I didn't really see very much stuff that was right if people did that sort of thing. So what you have to do for this problem is to write out the sum of the forces is equal to the mass times the acceleration. And the forces, we're just doing the two dimensions that we care about. Neither the normal force nor the weight are doing anything to make this thing move along the x-axis. It's all about these two forces, and of course you have to have friction. It doesn't say that there is friction, but it says find the coefficient of kinetic friction, so that means that there is friction. So your free body diagram would be these 3 red arrows. And so now that we have identified that Newton's second law is working in this scenario, we have the sum of the forces in the x direction adds up to the mass times the acceleration in the x direction, and then we have the sum of the forces in the y direction equals the mass times the acceleration in the y direction. But because this is moving along the x-axis, the acceleration in the y direction is 0. And so let's do the y components first, because up here you're going to see that the y component of F1 is 100 times the sine of 34. So 100 sine 34, and it's going to be minus this y component. So if you put a minus 20 here, this term will automatically come out negative. It's F2 times the cosine of 20. So the reason that I did not put in a minus 20 here is that I already stuck the minus sign, or sorry, this should be sine. I already stuck the minus sign out in front of this term. Regardless of whether you do plus F2 sine of minus 20 or minus F2 sine of positive 20, this should be a negative term right here. So when you do that, you can solve for F2. F2 equals, and you can get the number for that. So the other component, the x component, is a little bit more tricky because it has the force in it here, or the friction force, But what that's going to look like is minus the friction force plus 100 cosine 34 plus F2 times the cosine of 20, and you can put minus 20, it doesn't matter, it comes out to be the same thing, and that's going to equal MAX. So the AX, you might worry that we have too many unknowns here, but we just solve for F2, and the friction force is equal to mu n, so that's mu mg. So this is the thing we want to solve for, the coefficient of kinetic friction. The mass is 30 kilograms, g is 9.8 like it always is, and the acceleration we get from the fact that the box starts from rest, moves 50 meters in 8 seconds. So the way that we find that is to use this equation, x equals x naught plus v naught x t plus 1/2 ax t squared. And so x is where it winds up, which is 50 meters. It starts at position 0. It starts from rest. And then 1/2 ax, what we would like to solve for, and then the time is 8 seconds. And so the acceleration, you can solve for that. So that's your ax. And then this goes into here, and you can solve for the coefficient of kinetic friction is the only thing that you don't know.